We've codified our existence to bring it down to human size, to make it comprehensible. We've created a scale so that we can forget its unfathomable scale.
Previously on moons, we've explored the potential resources hidden within moons and planetary bodies. Resources that could play a pivotal role in humanity's future beyond Earth. In today's episode, we consider an even more ambitious concept: embryo space colonization. Imagine a future where humanity, facing an uncertain future on Earth, sends frozen embryos across the stars to establish life on distant worlds. This bold approach, still theoretical, could one day be our best hope for expanding human civilization to new uncharted territories. I, Hatshepsut, Pharaoh of the Two Lands, look upon your quest to explore the stars and feel awe for your ingenuity. You seek to do what we could only dream of. Reach beyond the skies, plant seeds of life, and expand the boundaries of existence itself. The journey of embryo space colonization begins with a very deliberate and calculated mission: sending embryos, frozen at an early stage of development, on a journey to a distant moon or planet. This concept has captured the imagination of scientists and visionaries alike, as it presents a potentially viable path for humanity's future beyond Earth. The challenge begins with choosing a destination. Many moons in our own solar system, such as Europa, a moon of Jupiter, or Enceladus, a moon of Saturn, are seen as promising candidates. These moons have subsurface oceans that could harbor the necessary ingredients for life: water, energy, and basic chemical compounds. While these moons may not be habitable in the traditional sense, their environments present an opportunity for humanity to begin anew, given the right technology and preparation. But before embarking on this great journey, humanity would first need to develop highly advanced technologies. The transportation of embryos alone presents unique challenges. Cryopreservation, the process of freezing embryos at early stages, is already well established on Earth. Modern science can preserve embryos for extended periods, even months or years, without harm. However, space travel introduces additional complications, such as extreme cold, radiation, and the physical demands of long-duration space travel. Spacecraft carrying embryos would need advanced life support systems to maintain stable temperatures and shield against radiation. These systems would be crucial for ensuring that the embryos stay viable during the voyage, which could take decades or even centuries. Once these embryos arrive at their destination, the next hurdle is how to bring them to life. Upon arrival at a distant world, the embryos would need to be thawed and developed in a controlled environment. This is where technology becomes even more critical. Artificial wombs, advanced bioengineered incubators, would be necessary to grow the embryos into full-term babies. These artificial wombs would not just need to support life during gestation, but also create a microenvironment where the embryos can grow without the aid of a human caretaker. Interstellar, as an example, presents a similar concept in the form of Plan B. In this scenario, the idea is to send thousands of frozen embryos to a new planet where they can be incubated and developed by advanced machines. The first group of embryos would be carefully monitored by AI systems to ensure they develop properly. Over time, the population would grow exponentially as the machines would continue to manage the embryo development, essentially creating a new society in the distant future. However, even this seemingly advanced solution comes with significant obstacles. The issue of genetic diversity looms large. If only a small number of embryos are sent, it would be crucial to ensure that the genetic pool remains diverse enough to prevent inbreeding and avoid genetic defects. To overcome this, genetic engineering may become necessary. With the right technologies, it might be possible to alter or select embryos to ensure genetic diversity in the growing population. Another key challenge lies in ensuring the health of the embryos during the journey itself. Even if the embryos are carefully preserved, the harsh conditions of space, radiation, microgravity, and extreme cold could still present risks. The embryos would need to be shielded from cosmic radiation, which could damage their DNA and lead to deformities or other complications. To address this, the spacecraft carrying the embryos would likely require robust radiation shielding, possibly using materials like water or other dense substances to create a protective barrier. This would be an expensive and technically challenging component of the mission, but essential to ensuring the embryo's survival. Once the embryos are safely delivered and thawed, the growth process begins. Artificial wombs would be used to develop the embryos until they reach full term. These high-tech incubators would mimic the conditions of a natural womb, providing nutrition, oxygen, and the right environment for the embryos to grow. Once they are born, the new generation of humans would grow in isolation without the familiar influence of Earth. This raises a significant ethical dilemma. Who is responsible for the well-being of these new humans? Who decides their education, their culture, and their future? As seen in Interstellar, where the characters rely on artificial intelligence to guide them to a new home, the role of AI would likely play a huge part in managing and overseeing the new colony. AI would be responsible for ensuring that the first generation survives, monitors the health of the population, and ultimately helps the colony thrive. But even as AI offers solutions, it also brings up another set of questions. How much control should AI have over the lives of these embryos turned humans? What ethical considerations are at play when you are raising a generation of humans in a controlled, artificial environment? The ultimate goal of this endeavor would be to create a thriving, self-sustaining colony. Over time, the population would grow, aided by technologies that could allow for the development of a society from the ground up. New generations could be born naturally from the original embryos, and eventually, the colony would reach a point where it could stand on its own, no longer relying on Earth. But for all the potential of this plan, the ethical questions loom large. The act of sending embryos across the stars, without their consent, without their knowledge of Earth, raises fundamental issues about autonomy, life, and the value of human experience. Would these future humans ever truly be human in the same sense as those on Earth? Would they be defined solely by their biology or by the world they are born into? As I reflect on this hypothetical journey, I see both promise and peril. To send life across the stars is to take on a great responsibility. These embryos may one day grow into humans, but they will not have the same experiences, the same history, or the same understanding of the world that we do. Their lives will be shaped by artificial means, by decisions made by others. The question is not just whether humanity can reach the stars, but whether we are prepared to create a new form of life that may never return to its roots. Technology will be the key to this journey. Technology to preserve, protect, and guide these embryos to life. But with that power comes the need for wisdom. We must ask ourselves, are we ready to shape the future of humanity in such a profound way? And in our quest to preserve life, we must never lose sight of the ethical responsibility that comes with it.